Okay, welcome to the video. Now we will talk about primality test. So primality test is generally like we are given a number and we need to check whether it's a prime number or not. So by brute force method it takes O of n time complexity, but we want to improve the time complexity. So can we do better? So can we check if a number is prime or not in less than O of n time complexity? So that's what our aim is. So let's dive into the video. So we use a mathematical fact for this. So the mathematical fact is like all divisors of a number n occur in pairs a comma b such that a star b equal to n. Okay, so now let's understand this mathematical fact by like exploring about few examples. So let's talk about divisors of 24. So we have divisors of 24 as 1 2 3 4 6 8 12 and 24. Now we will try to group these divisors into pairs such that the product of the numbers is equal to the is equal to our 24. So let's try to group the numbers. So we can group 1 and 24 such that 1 star 24 is equal to 24. We can group 2 and 12. So we can group 3 and 8, and we can group 4 comma 6. Okay, so let's take another example. So another example, let's talk about divisors of 32. Okay, so what are the divisors of 32? We have 1 we have 1 2 4 8 16 and 32. So now let's group this into pairs. So we have 1 comma 32, we have 2 comma 16, we have 2 comma 16, and now we have 4 comma 8. Okay, so 4 comma 8. Okay, so did you observe any one thing, any similarity or anything that we can extract from this mathematical fact and that can be used in primality test to reduce the time complexity? So one thing is like observe the first numbers in the pairs. Like here in this divisors of 24 example, we have the largest, the largest number in a pair is 4. So let's talk about only the first numbers in a pair. So we have 1 comma 2 comma 12, 1 comma 2 comma 3 comma 4. And now here the same, like let's talk about the first numbers. We have 1 comma 2 comma 4. So I'm talking about these numbers, like 1 here, 2 here, 3 here, and 4 here. Okay, so here also 1 here, 2 here, and 3 here. Now let's talk of the highest number possible. So from this 1 2 and 4, the highest number is 4, and from this 1 2 3 and 4, the highest number is 4. So for 12 you got the highest number as 4. For 32 also you got the highest number as 4. So can you find any similarities in this? Okay, so for to check whether 24 is either a prime or not, we need not go from 2 to 23. This is basically the brute force method, in which we will go from 2 to the number n minus 1 to check whether a number n is either prime or not. But we need not go for that. So we can check up to root n. So if we have a, if we have a number n, one divisor will always lie below root n, and the other divisor will always lie above root n. So if it is like like one divisor can be less than or equal to root n, the other divisors can be greater than or equal to root n. Okay, so they always occur in pair. If one is less, then definitely if in the range from 1 to root n, if one divisor occurs, then in the range from root n to n, definitely there will be another number such that the first one and the second will form pairs such that a star be equal to n. So basically we need not check up to n, so we can check just up to root n. So basically, like, so now we can write the program. So let's write the program. So suppose, like, we'll return bool check prime. Suppose, let's say we are given an integer n. So if n equal to 1, so let's return false. Return false. Now now for the other cases, for j equal to, for int j equal to 2, j less than or equal to sqrt of n j plus plus. Okay, so if n percentage j equal to 0, then we return false, it's not prime, else return true. So this is generally the primality test. So by using this we can check whether a number n is either prime or not. So we know we need not go up to n, so we can stop up to root n. So in root n itself we can check whether a given number is prime or not. This is the best method possible to check whether a given number is either prime or not. Thank you.